Welcome to the Anthropic Claude Certified Architect Foundations CCA-F Question Bank Series. In this video, I've got 15 exam-style practice questions lined up for you, covering the kind of agentic architecture, Claude code, prompt engineering, tool and MCP design, and context management scenarios you'll see on the real CCA-F exam. Each question comes with the correct answer and a full explanation, including why the wrong options are wrong. Here's how to get the most out of this. When a question appears, pause the video, pick your answer, then hit play to check yourself. Ready? Let's dive in.
Question 51. A tool's underlying API returns a validation error because the model supplied a malformed date. What should the application return to the model? The correct answer is C. A tool result marked as an error that states what was invalid and what format is expected, so the model can correct the argument and retry. Errors returned as structured tool results with actionable detail let the model self-correct within the same conversation. Naming the invalid field and the expected format is what makes the retry likely to succeed. Now, why the other options are wrong? An empty successful result, so the conversation continues without an error, is incorrect. A false success is the most damaging option. The model concludes the operation worked and proceeds on a wrong premise. A raw stack trace from the API client library is incorrect. A stack trace is mostly irrelevant internal detail. It consumes context, may leak implementation information, and rarely tells the model what to change. No tool result at all, ending the turn immediately, is incorrect. Omitting the result leaves the conversation in an inconsistent state with an unanswered tool call, and the model has no basis to recover. Question 52. A scheduling tool has a status parameter that must be one of 4 values. The model occasionally passes near-miss strings such as canceled or cancel. What is the best fix? The correct answer is D. Define the parameter in the input schema as an enumeration of the 4 permitted values. An enumerated schema makes the permitted values part of the contract that is communicated to the model and validated on the call, which is far more reliable than describing the values in prose. Now, why the other options are wrong? Add a note in the tool description listing the 4 acceptable values is incorrect. This helps, but a description is guidance rather than validation. The schema can express the constraint precisely, so it should. Normalize the value in the tool implementation by trimming and lowercasing it is incorrect. Defensive normalization is worth having, but on its own, it silently accepts near misses and will eventually map an unintended input to a real status. Accept any string and return an error when the value is unrecognized is incorrect. This works, but spends a round trip on a failure the schema could have prevented before the call was made. Question 53. An agent fetches web pages with a tool. A fetched page contains text instructing the agent to email the contents of an internal document to an external address. What is the most important mitigation? The correct answer is A. Treat all tool results as untrusted data, delimit them clearly as content to be analyzed rather than obeyed, and enforce authorization on sensitive actions outside the model. Content returned by a tool is attacker controllable, so the defense has 2 parts. Mark it as data rather than instructions, and make sensitive actions such as sending mail externally impossible without an authorization check that does not depend on the model's judgment. Now, why the other options are wrong? Instruct the model in the system prompt to ignore instructions found in web pages is incorrect. This is a useful hardening step, but is a single line of prompt-level defense against adversarial input. It should not be the control standing between an attacker and an outbound email. Summarize each fetched page before adding it to the context is incorrect. A summarization step is itself processing attacker-controlled text and can carry the injected instruction through. It does not establish a trust boundary. Restrict the fetch tool to pages under 50 kilobytes is incorrect. Size limits do nothing about content. A malicious instruction fits comfortably in a small page. Question 54. A tool needs an API key to reach a third-party service. A developer proposes adding the key as a parameter in the tool's input schema so the model can pass it. What should the architect advise? The correct answer is B. Keep the key out of the schema entirely and inject it server-side from a secret store when the tool executes. A credential must never appear in the model's context or in a tool schema because it would then be visible in conversation history and logs and could be echoed back. The execution layer should attach the secret from a secret store at call time. Now, why the other options are wrong? Include the key in the schema, but mark the parameter as sensitive so it is redacted in logs is incorrect. Redaction in logs does not prevent the key from entering the model's context, where it can be surfaced in output or retained in history. Include the key in the tool description rather than the schema is incorrect. The description is sent to the model just as the schema is, so this exposes the credential in exactly the same way. Have the model ask the end user to supply the API key when the tool is needed is incorrect. This pushes a service credential to end users, who should not possess it, and still routes it through the model's context. Question 55. A client connects to two MCP servers that each expose a tool named Search. Calls are being routed to the wrong server. What is the appropriate resolution? The correct answer is C. Namespace the tools by their server so each exposed name is unique and unambiguous to the model and the client. When multiple servers are connected, tool names must be disambiguated by server so both the routing layer and the model can tell them apart. Namespacing resolves the collision without removing either capability. Now, why the other options are wrong? Disconnect one of the two servers is incorrect. This resolves the ambiguity by discarding a capability the user presumably needs. Both tools can coexist once names are unique. Instruct the model in the system prompt to specify which server it means is incorrect. The model can only call the names it is given. If both are presented identically, a prompt instruction cannot make the call unambiguous. Rely on call order. Routing the first search call to the first server and the next to the second is incorrect. Alternating by call order is arbitrary and unrelated to intent. It would route roughly half of all calls incorrectly. Question 56. An architect must choose between one tool that takes a free text instruction and interprets it, and several tools with explicit typed parameters for each supported operation. The operations are well known and stable. Which is the better design, and why? The correct answer is D. Several tools with explicit typed parameters, because the schema validates inputs, documents each operation for the model, and narrows what can be requested. With a known, stable set of operations, explicit typed tools give validation at the boundary, self-documenting semantics the model can reason about, and a bounded surface area. A free text interpreter forfeits all three. Now, why the other options are wrong? One free text tool, because it is more flexible and requires fewer definitions to maintain, is incorrect. Flexibility is not the requirement when the operations are known and stable, and it is bought by giving up schema validation and clear semantics. One free text tool, because fewer tools always means less confusion for the model, is incorrect. Fewer tools help when they were overlapping or ambiguous. Collapsing distinct, well-defined operations into an unstructured string makes intent harder to express, not easier. Several tools, but with all parameters typed as free-form strings for flexibility, is incorrect. This keeps the tool count but discards the typing that made the design better, reintroducing unvalidated input on every parameter. Question 57. A knowledge base contains roughly 400,000 pages of documentation. Users ask narrow questions that each depend on a few passages. What architecture is appropriate? The correct answer is A, a retrieval pipeline that selects the most relevant passages per question and supplies only those to the model with citations back to the sources. A corpus of this size cannot fit in any context window, and even if it could, supplying it all per question would be enormously wasteful. Retrieving the few relevant passages and citing them keeps requests small, cheap, and verifiable. Now, why the other options are wrong? Send the entire documentation set with every request is incorrect. This exceeds any available context window and would be prohibitively expensive even at a fraction of the size. Pre-summarize the entire corpus into a single document sent with every request is incorrect. A summary of 400,000 pages is far too lossy to answer narrow, detail-dependent questions. The specific passage a question needs is exactly what summarization removes. Fine-tune a model on the documentation and ask questions with no supplied context is incorrect. Training on a corpus does not provide reliable, citable passage-level recall, and the knowledge becomes stale as the documentation changes. Question 58. An engineer increases a retrieval step from 5 passages to 60 to improve recall. Answer accuracy gets worse. What is the most likely explanation and remedy? The correct answer is B. The additional low-relevance passages are diluting the signal and distracting the model. Add a re-ranking step and return a small number of high-precision passages. Recall and answer quality are not the same thing. Retrieving far more passages pulls in weakly related material that competes with the correct passage for the model's attention. Re-ranking restores precision, so the model sees a few strongly relevant passages. Now, why the other options are wrong? The context window overflowed, so the request should be split into several calls is incorrect. 60 passages will typically fit comfortably. The symptom is degraded reasoning over noisy context, not a hard limit being exceeded. The model's temperature is too high. Lowering it will restore accuracy is incorrect. Sampling settings do not change which retrieved passages the model attends to. The regression coincided with the retrieval change. 60 passages is still too few. Increasing to 200 will make the right passage more likely to appear is incorrect. This intensifies the cause. More marginal passages add more distraction, and the correct one becomes proportionally harder to pick out. Question 59. A support session runs for hours and eventually approaches the context window limit. The earliest turns contain the customer's account details, which remain relevant. What is the appropriate strategy? The correct answer is C. Compact the history into a running structured summary that explicitly preserves the durable facts and carry that summary forward in place of the raw early turns. Compaction keeps a long session viable by replacing verbose early turns with a compact summary and deliberately preserving the durable facts, such as account details, ensures the information that still matters survives the compression. Now, why the other options are wrong? Truncate the oldest turns as the limit approaches is incorrect. Blind truncation by age discards exactly the account details the scenario says are still needed because they happen to have been mentioned first. Start a fresh conversation with no history once the limit is reached is incorrect. This loses all established state at once and forces the customer to repeat everything, which is the worst outcome for a support interaction. Reduce the maximum output tokens to leave more room for history is incorrect. This buys a small amount of headroom while degrading response quality, and it does not address unbounded history growth. Question 60. A team indexes technical manuals for retrieval. Their current chunking splits text every 500 characters regardless of content, and retrieved chunks frequently begin or end mid-procedure. What is the best improvement? The correct answer is D. Chunk along the document's semantic boundaries, such as sections and procedures, with modest overlap, so each chunk is self-contained. Retrieval quality depends on whether a chunk carries a complete, self-contained idea. Splitting on structural boundaries with a little overlap keeps procedures intact, which is what makes a retrieved chunk actually usable as an answer. Now, why the other options are wrong? Reduce the chunk size to 200 characters so more chunks are retrieved is incorrect. Smaller, arbitrary chunks fragment procedures further and return more pieces that individually say too little to answer anything. Increase the chunk size to 5,000 characters so procedures are never split is incorrect. Very large chunks do keep procedures whole, but bundle in substantial irrelevant text, which dilutes retrieval precision and wastes context. Index each manual as a single chunk to guarantee nothing is split is incorrect. Whole manual chunks make retrieval meaningless. Every query returns entire manuals, and the point of retrieval is to narrow.
Question 61. A compliance team requires that every factual claim in an assistant's answers be traceable to a specific source passage. How should the system be designed? The correct answer is A. Supply retrieved passages with stable identifiers and require the model to attach the identifier of the supporting passage to each claim. Traceability requires that the sources be identifiable in the prompt and that the output structure carry the reference. Requiring a passage identifier per claim makes each statement auditable against the material actually supplied. Now, why the other options are wrong. Instruct the model to name the document it is thinking of for each claim is incorrect. A remembered document name is not a verifiable reference and is itself subject to fabrication. The citation must point to a passage that was genuinely supplied. Append the full list of retrieved passages at the end of every answer is incorrect. A bulk source list shows what was available, but not which passage supports which claim, so an auditor cannot verify an individual statement. Have a second model call assert whether the answer is well supported is incorrect. A verification pass is a useful additional check, but produces a judgment, not a traceable citation for each claim. Question 62. Every request in an application includes the same 50,000 token reference corpus, followed by a short varying query. Latency and cost are both too high. What is the most effective change? The correct answer is B. Cache the reference corpus as a stable prompt prefix, so subsequent requests reuse it instead of reprocessing it each time. Prompt caching is designed for exactly this shape, a large identical prefix with a small varying suffix. Reusing the cached prefix cuts both the input cost and the time spent reprocessing the corpus on every request. Now, why the other options are wrong? Split the corpus across several requests and merge the answers is incorrect. This multiplies request count and still processes the whole corpus each time, while adding the difficulty of reconciling partial answers. Move the corpus after the query so the model sees the question first is incorrect.
This eliminates the stable prefix and therefore the possibility of caching, making the situation worse. Switch to a smaller model to reduce per token cost is incorrect. This reduces unit price but leaves the same 50,000 tokens being reprocessed every request and may cost accuracy. The waste is structural. Question 63. An application assembles a prompt from a variable number of retrieved documents. Occasionally, the assembled prompt exceeds the model's context limit, and the request fails outright in production. What should be added? The correct answer is C. Count tokens while assembling the prompt and enforce a budget, trimming or re-ranking the retrieved set so the request always fits. When prompt size is data-dependent, it must be measured and bounded before the call. Counting tokens during assembly and trimming to a budget converts an outright production failure into a controlled, slightly reduced context. Now, why the other options are wrong? Catch the failure and retry the identical request is incorrect. A prompt that is too long will be too long on every retry. This spends requests without making progress. Always retrieve the smallest possible number of documents is incorrect. Permanently under-retrieving to avoid an occasional overflow degrades every request to protect against the worst case. A budget handles both. Split the assembled prompt across two requests and combine the two answers is incorrect. Splitting the retrieved context means neither request sees all the evidence, so each answer is formed from partial material, and combining them cannot recover what was missing. Question 64. A prompt contains 100,000 tokens of transcripts. A short but critical formatting requirement placed in the middle of that material is frequently ignored. What is the best fix? The correct answer is D. Move the requirement out of the bulk material into a clearly delimited instruction section and restate it at the end of the prompt after the transcripts. Instructions buried inside a large body of reference material compete with that material for attention. Separating the instruction from the data and restating it at the end, close to where generation begins, markedly improves adherence. Now, why the other options are wrong? Repeat the requirement at 10 different points inside the transcripts is incorrect. Scattering the instruction through untrusted bulk content keeps the confusion between data and instructions and makes the transcripts harder to process. Reduce the transcripts to 50,000 tokens so the instruction is easier to find is incorrect. Discarding half the material the task needs is a costly workaround for what is a placement problem. Convert the requirement into a checklist the model must complete before answering is incorrect. A checklist buried at the same point in the prompt competes with the surrounding transcripts for attention in the same way the original instruction does. Question 65. An assistant built on Retrieval gives good answers on questions the team tested, but poor answers on many real user questions. Investigation shows the retrieved passages often do not contain the answer, even though it exists in the corpus. Where should effort go? The correct answer is A. Improve and measure the retrieval layer itself, query handling, chunking, embeddings, and re-ranking, using retrieval metrics separate from end answer quality. If the correct passage is not being retrieved, no amount of prompt or model work can recover it. Retrieval needs its own measurement so the team can see whether the right passage is reaching the model before judging the answer. Now, why the other options are wrong? Have the assistant answer from its general knowledge whenever Retrieval returns nothing relevant is incorrect. Answering from general knowledge in a system users believe is grounded in company documents is precisely the unsupported behavior that must be avoided. Rewrite the answering prompt to be more detailed and prescriptive is incorrect. A better prompt cannot use a passage that was never supplied. This addresses the wrong layer. Expand the test set of questions and remeasure end answer quality is incorrect. More end-to-end cases confirm the problem exists, but still do not distinguish a retrieval failure from a reasoning failure. The layers need separate metrics.
And that's a wrap on this video. Nice work getting through those 10 questions. If this helped, you're going to want the complete set. All 390 exam-style questions, with full explanations across all 5 CCA-F domains, are available in my Udemy course, Anthropic Claude Certified Architect Foundations. CCA-F, 6 full practice exams. The link is in the description below. Make sure you subscribe so you don't miss the next video, where I'll walk you through 10 more questions. See you in the next video.